Hey you guys, this is Mr. Millings, and in this video we are going to learn how to do some solution stoichiometry. And before we start doing some solution stoichiometry, here's a little disclaimer for you. It says that prior knowledge of the topics below are essential before watching this video, and I recommend that you first watch the video on molarity followed by the video on mass stoichiometry before you start in on this video on solution stoichiometry explained. So let's jump right in with some solution stoichiometry. And so when we're performing some solution stoichiometry, we can use this little diagram here to help us along. And it says right here that when performing solution stoichiometry, the diagram below can be used as a guide. And it also says that whenever we're performing some solution stoichiometry, to never start the problem with the molarity of the known solution. Rather, if the mass of the known substance is not given, then start the problem with the volume of the known substance or solution. Okay, so that's an important concept. So if we take a look at this little solution stoichiometry diagram, this little diagram is going to help us solve all kinds of problems dealing with solution stoichiometry. So let's go ahead and use this diagram here and apply it to 3 different example problems, and hopefully you catch on. So in this very first example, it says how many milliliters of 2.5 molar hydrochloric acid are needed to completely react with 275 milliliters of 1.5 molar magnesium hydroxide according to the chemical reaction below. So we have a chemical reaction, and what this chemical reaction is telling us is that we have a solution of magnesium hydroxide reacting with hydrochloric acid, and what ends up being produced is a solution of magnesium chloride and water, it looks like. And so what this is asking is how many milliliters of 2.5 molar HCl are needed. So what we want to figure out is how many milliliters of 2.5 molar HCl are needed to completely react with 275 milliliters of 1.5 molar magnesium hydroxide. So here's our known substance. It's telling us we have 275 milliliters of this solution right here that has a concentration of 1.5 moles per liter, or 1.5 molar. Okay, so if we take a look at our little diagram here, the known substance, or substance A we will just call it, is expressed in milliliters. So we know the volume of our known stuff, or our known solution, or this magnesium hydroxide. And so whenever we're doing some solution stoichiometry, we always want to start with the volume, not the molarity or concentration of the known solution. So in this problem here, we have 275 milliliters of magnesium hydroxide. And so what we want to do is we want to figure out, if we take a look at this problem here, how many milliliters of 2.5 molar HCl will be needed to completely react. So we're trying to figure out the volume of our unknown, or our solution of hydrochloric acid. And so that's what we're being asked to determine. So let's go ahead and do the stoichiometry problem right here. If we take a look, we have 275 milliliters of our solution, of our known solution. However, our known solution needs to be expressed in liters. So the very first thing we're going to have to do is convert the milliliters to liters, and so we're going to put milliliters of MgOH2 on the bottom here. And we're going to convert this to liters of MgOH2, and so we'll put that at the top. And so we know there's 1,000 milliliters in 1 liter. And so that's going to bring us to this step right here. And so what we now need to do is multiply it by our concentration. What is the concentration? It tells us it's 1.5 molar. And this capital M stands for moles per liter. There's 1.5 moles of magnesium hydroxide dissolved in every 1 liter of this solution right here. And so if we take a look, we want to cancel out liters of magnesium hydroxide, so we'll put that at the bottom, and we want to convert this to moles of magnesium hydroxide, and so we're going to put that at the top. And if we take a look at our concentration, this is telling us 1.5 moles of magnesium hydroxide, 1.5 moles for every 1 liter That's what this unit means, moles per liter. And so that is this step right here. That's what we just did right here. And that's going to bring us to this right here. But we don't want to figure out the moles of our known substance. We want to figure out the moles of our unknown substance, so that way we can carry on to this step right here and eventually to this step right here. And so what we now need to do is multiply by our mole ratio. If we take a look at our mole ratio compares the stuff we're trying to find, which is this stuff right here, to our known stuff, which is this stuff right here. And what this is telling us is that there are 2 moles of hydrochloric acid that are reacting with 1 mole of magnesium hydroxide. And so we want to cancel out moles of magnesium hydroxide, so we're going to put that at the bottom. And we're going to convert this to moles of HCl, so we're going to put that at the top. And if we look at our mole ratio, there's 2 moles of this to an imaginary 1 mole of magnesium hydroxide. And so now that's that step right there. And so what we now need to do is multiply by our concentration of the unknown solution, or the unknown volume, which is our hydrochloric acid. And it's telling us it's 2.5 molar. And so once again, what this means, what this capital M means, is moles per liter. And so we want to cancel out moles of HCl. And we want to convert this to liters of HCl. And so the concentration here, it's telling us is 2.5 moles for every 1 liter. And we're running out of room here, but we're going to make this work here. If we take a look, this will give us the liters of solution. The question here is asking to figure out milliliters. So we want to cancel out liters of HCl. We want to convert this to milliliters of HCl. And so 1 liter is 1,000 milliliters. And so that's how we're going to set this problem up. And so now we take 275 divided by 1,000. Times 1.5 times 2 divided by 2.5 times 1,000. And we're going to end up with 330 milliliters. I'll put our final answer down here. 330 milliliters of HCl. So how did we get this unit? Well, milliliters of magnesium hydroxide on top and bottom cancel. Liters of magnesium hydroxide on top and bottom cancel. Moles of magnesium hydroxide on top and bottom cancel. Moles of HCl on top and bottom cancel. Liters of HCl on top and bottom cancel, leaving us with milliliters of HCl. So, how many milliliters of 2.5 molar HCl are needed to completely react with 275 milliliters of 1.5 molar magnesium hydroxide? It looks like 330 milliliters of hydrochloric acid will be needed. Let's take a look at another problem. In our second example, it says 55 milliliters of 2.5 molar silver nitrate reacts with copper wire according to the reaction below. We have to calculate the mass of silver produced. So it looks like we want to figure out the mass, or the amount of grams of silver that will be produced if we have 55 milliliters of silver nitrate that has a solution of silver nitrate that has a concentration of 2.5 moles per liter. So if we take a look, our starting stuff is this stuff right here, and we know the volume of our starting stuff, or our solution A, we will call it, and we want to figure out the mass in grams of substance B. And so we're going to start right here. We're going to work this little process all the way up to here. So if we take a look, we're starting off with 55 milliliters of AgNO3. 55 milliliters of AgNO3. And so when we're working some solution stoichiometry problems, we're going to want to convert the milliliters to liters. So let's go ahead and do that. We're going to cancel out milliliters of AgNO3, so we'll put that at the bottom. And we're going to convert this to liters of AgNO3, and so we'll put that at the top. And we know there's 1,000 milliliters in 1 liter. And so that's our first step. Now what we have to do is multiply by our concentration. We're going to multiply by our concentration of our known stuff, which is 2.5 moles per liter, right? We know that the concentration is 2.5 moles per liter of AgNO3, and we want to cancel out liters of AgNO3, so we're going to put that at the bottom here. We want to convert this to moles of AgNO3, so we'll put that at the top, and it looks like the solution's concentration is 2.5 moles for every liter of solution. So that's going to bring us to this point right here. But we don't want to be right here. What we want to do is we want to figure out how many moles of the unknown stuff of the silver are going to be produced. So if we take a look at our balanced chemical equation, it looks like there's 1 mole of silver for every one mole of silver here for every 1 mole of AgNO3. There's an imaginary 1 in front of each one of those. So if we take a look, we want to cancel out moles of AgNO3, so we'll put that at the bottom. We want to convert this to moles of silver, so we'll put that at the top. And there's a 1-to-1 ratio. 1-to-1 ratio. And so that's going to bring us here, but we don't want to be here. We're trying to figure out the grams of Ag of silver. And so what we now need to do is multiply by the molar mass of silver. So if we look on our periodic table of elements, silver's molar mass is 107.87 grams per mole. And so we want to cancel out moles of silver, so we'll put that at the bottom. We're going to convert this to grams of silver, so we'll put that at the top. And 1 mole of silver is 107.87 grams. And so that's how we're going to set this problem up. And so we take our calculator out and we'll take 55 divided by 1,000 times 2.5 times 107.87, and we're going to end up with 15. If we use the correct number of sig figs, there's 2 here and 2 here, our answer should only have 2 sig figs. 15 what? Well, milliliters of AgNO3 cancels with this one. Liters of AgNO3 on top and bottom cancel. Moles of AgNO3 on top and bottom cancel. Moles of Ag on top and bottom cancel, leaving us with grams of silver. So how many grams of silver will be produced if we have 55 milliliters of a 2.5 molar solution of AgNO3? It looks like 15 grams of silver will be produced. Let's take a look at one final example. In this third example, it says if 35 grams of magnesium chloride is produced in the chemical reaction below, then how many milliliters of 0.75 molar HCl will be consumed? So if we take a look, it's telling us how many grams of magnesium chloride were produced. We have 35 grams of this stuff produced. And then if we take a look, we want to figure out how many milliliters of 0.75 molar HCl will be consumed. So we want to figure out how many milliliters of 0.75 molar HCl will be consumed if this many grams of magnesium chloride is produced. So the known stuff, if we take a look here, is expressed in grams, right? Or it's given the mass of our known stuff, right? 35 grams. And what we're asked to figure out is the volume. We want to figure out the volume of this solution right here, or of our hydrochloric acid. And so we'll have to go ahead and use this diagram to go through and figure this out. And so let's go ahead and do that. If we take a look, we're starting off with 35 grams of MgCl2. And the very first thing that we need to do here is we have to figure out the molar mass of MgCl2, so that way we can convert it to moles right here. And so what is the molar mass of MgCl2? Well, if we take a look at our periodic table, magnesium is 24.31 grams per mole. Chlorine, because we have 2 of them, we're going to multiply it by 35.45 grams per mole. And we're going to add these 2 together. So when we take 35.45 times 2 and add 24.31 to it, we'll end up with 95.21. So we want to cancel out grams of magnesium chloride. We'll put that at the bottom and convert to moles of magnesium chloride, and we'll put that at the top. And so 1 mole of magnesium chloride is 95.21 grams. And so that's what we just did right here. And that's going to bring us to the amount of moles of magnesium chloride that we have. But we don't want to figure that out. What we want to do is we want to figure out how many liters or milliliters, of this hydrochloric acid there are. And so what we have to do now is multiply by our mole ratio to go from here to here. What is our mole ratio going to be? Let's take a look. The stuff we're trying to find is our hydrochloric acid, and the known stuff is our magnesium chloride. And if we take a look, there's a 2 to this imaginary 1 ratio right here. And so we want to cancel out moles of MgCl2, so we'll put that at the bottom of our equivalency statement. We're trying to figure out moles of HCl, so we'll put that at the top. And our balanced chemical equation is telling us that there's 1 mole of MgCl2 to 2 moles of HCl. And so that's going to bring us right here, but we don't want to be right here. We now need to figure out the volume in liters of our hydrochloric acid. And so if we take a look, we need to multiply this by the concentration of our hydrochloric acid. The concentration of our hydrochloric acid is 0.75 molar. Whenever we see this capital M, this means moles per liter. There's this many moles of hydrogen chloride dissolved for every 1 liter of water. There's 0.75 moles dissolved for every 1 liter of water. And so we want to cancel out moles of HCl. We'll put that at the bottom here. We're going to convert this to liters of HCl first. And so this is telling us that there's 0.75 moles of HCl for every 1 liter. And in the very last step, what we need to do is we need to cancel out the liters of HCl and convert to milliliters of HCl. If we read our question carefully, it's asking to figure out the milliliters of our hydrochloric acid. And so we know that there's 1,000 milliliters in 1 liter. So we just take our calculator out, we take 35, and we're going to divide this by 95.21, multiply by 2, divide by 0.75, and then multiply by 1,000, and we're going to end up with 980 what? Well, let's see here. Grams of magnesium chloride cancels. Moles of magnesium chloride cancels. Moles of HCl cancels. Liters of HCl cancels, leaving us with milliliters. And we have 2 sig figs here, and it looks like we have our answer can only be 2 sig figs. So there we go. 980 milliliters of hydrochloric acid will be consumed. So that's solution stoichiometry in a nutshell, and I hope you guys found this helpful.